Hey there, you rates. Mr. Herman here, and this is exercise 4B, circumference of a circle. The learning goals for this lesson is to know the meaning of the terms diameter, radius, and circumference, and to also understand that pi, is a number that equals the circumference divided by the diameter of any circle. The success criteria for this lesson is to be able to find the circumference of a circle using a calculator. Now, circumference of a circle and the symbol pi that you just saw before, yes, the same one that I have on my arm, which is a tattoo. What we'll be looking into is how to find the perimeter of any circle. But we don't call it a perimeter when it comes to a circle, we call it a circumference. Now, there are two main features within a circle. Other than the circumference, we have the diameter, which is a line that reaches from point to point, and it's the largest line that you can fit within a circle. So obviously we can draw a line anywhere within the circumference. We can draw a line from there to there. These lines are called secants. They cut across. The longest line that you can obtain within a circumference is called the diameter. The second key feature is the radius, which is the central point within a circle. That line there goes from the central point to the edge of a circle. Now, the radius can be anywhere. In this particular diagram, the radius is from the center right to the bottom, but I can draw a radius. If this is the center, I can do a radius, say there, or I can do a radius over here, or that angle. That measurement for this particular circle will be the same length. So the diameter is the distance across the center of a circle, and the radius is the distance from the center to the circle, which is the edge of the circle. Now notice that the diameter here is the same as getting two lengths of the radius. I can fit a radius within here and within here. So there's this little formula here which says that the D is equal to 2R. So let's dissect this a little bit. D is equal to 2R. So D is meaning the diameter. This here is the diameter, and R stands for radius. And remember, when there's a number next to a letter, this just means 2 times R. So what this is saying is the diameter is the same as 2 lots of the radius, and that makes sense. There's one radius here and another radius here. So you might see this formula pop up at times. This is all that means, that the diameter is 2 lots of the radius. Now, in the real world, when we measure the perimeter of a certain shape, say a square, rectangle, or triangle, all you have to do is just add up the side lengths and get a certain measurement. The problem we face, or we run into when it comes to a circle, is that, well, yes, it's easy to maybe obtain a perimeter or circumference of a circle that's drawn on a paper, but in the real life world, it's not as comfortable or as easy. Yes, you can have tape measures that maybe measure around a certain shape. That gets a bit too uncomfortable. So what we do is we use a certain number, which is this. And this right here is pi, Pi. It's a Greek letter, which is used within a perimeter. I think it stands for the letter P, I'm pretty sure, coincidentally. So how does this, and we all know this is 3.14. It does keep going on and on and on. How does this tie with finding the circumference of a circle? So what a lot of mathematicians did back in the early days is just try to find a relationship between the circumference of a circle and its diameter. So say, for instance, we got the circumference of a certain circle and we had the ability to measure it. And we draw this circle, we get the perimeter, and it's 14.01 millimeters. Then on that same circle, we get the diameter, and it's 4.46. So in other words, we draw the circle. I'm only going to do it for this one, and we go right around from end to end, and this is 14.01 millimeters. And then the diameter, remember the diameter is that line that goes across from end to end. This is 4.46 millimeters. Okay, so we've got these two different measurements. Let's just take the circumference and divide it by the diameter and see what we get. So get the calculator out. So we're going to get the circumference, so 14.01 And we're going to divide this by 4.46. And if it comes up with this, you just press the SD button, 3.1412. So here, this measurement is 3.1412. Okay. Looking quite familiar to this 3.14. Maybe it's just a coincidence. Let's try the second one. We have another circle, 37.32. And this is divided by its diameter, 11.88. So now this time we've got a bigger circle. We measure the outside, it's 37.32. And we divide this by 11.88, which is diameter. And we end up getting 3.141414. So 3.1414, and this continues on. Okay, there seems to be some type of link between the circumference divided by its diameter of any circle. Try one more time. Try 128.76. We're going to divide this by 40.99. 3.1412. Okay, so there's a link of some sort. Any circle that you draw, if it's a perfect circle, the better, and you get its length, its circumference, and you divide it by whatever the length of the diameter is, you will get 3.1412 or 3.14 for the very least. And you can even try this at home. You can, to the best of your ability, try to measure something that is a circle, get its length. Maybe you can use a piece of string and use that string to obtain the length, map it up to a ruler, and then you can also obtain the circumference, not up circumference, sorry, the diameter, and do the circumference divided by diameter. Sure enough, you will get 3.14 something something. The closer you are to this number, the more accurate you are with your measurement. So where is this pi number on our calculator? So if you have a scientific calculator, it's actually quite hidden. It's right on the bottom here. In order to get that, you have to press the shift button and then press this times 10 to the power of x. And here you'll see this little pi pop up. And you can press equals on this and press SD, and it will pop up with the accurate version of what pi is. So 3.14159265. Now this is a number that keeps going on forever. The calculator doesn't have enough space to actually show it, but this is an infinite amount of numbers after. We just use 3.14 if we don't have a calculator handy. Alright, so now that we know that the circumference divided by the diameter, so the circumference divided by diameter is equal to pi, we can manipulate this equation here to help us try to figure out how we can work out the circumference of a circle if we know what the diameter is. So if we need to try to find the circumference of the circle and we know its diameter, we can use these two formulas here. So to get the circumference, I'm looking at this one first. We can just get pi and then multiply it by its diameter. Okay, so we can get pi, 3.1415, etc., and times it by the diameter. So if you give me a circle, don't know what the circumference is, you tell me what the diameter is, just times it by pi, and you can get your circumference. Remember, C stands for circumference, and D stands for diameter. The other case is C is equal to 2 pi r. This is just saying that if maybe the diameter isn't being given, but maybe the radius has been given. In order to get the circumference of this, you can take the radius, multiply by 2, and then times it by pi. And remember, 2 lots of radius is the diameter. So that's why we have this 2 times pi times r. Maybe 2 times r times pi is a better format for it, but this is the most common template format of it, 2 times pi times r. So you use this formula here if only the radius has been given, and you use this formula here if only the diameter has been given. Let's try a few examples and see how easy this formula is in order to obtain a circumference of a circle. Okay, we're going to find the circumference of these circles corrected to decimal places, and we're going to use a calculator value for pi. The first one here, we have a circle here, and we're trying to find the outside length. And the formula that we need to use, what's been given here is the radius. The radius is 3.5 meters. So the one that requires a radius within the formula is this one here. C is equal to 2 pi r. We know what the radius is, r, it's 3.5. So the circumference is equal to 2 times pi times 3.5. Now I'm writing it out as this notation so you can see what it is that you need to put into the calculator. The circumference is equal to 2 times pi, so remember pi is shift and this button here, times 3.5. You might get 7 pi. I want you to press the SD button if that pops up. And the number that we have here is 21.99. So 21.99. So very close to 22 centimeters. Or 22 meters, sorry, because this is in meters. So we have to write the notation of meters afterwards. So all we did was just use the relevant formula, plugged it into the calculator, and let the calculator do the rest. 21.99 meters is the answer, and this is to 2 decimal places. Because that critical digit after the 9 here is 1, that 9 stays the same, so 21.99 meters. Second formula, here we have the diameter that has been given. So the diameter in this case is 4 centimeters. We're using this formula here. Circumference is equal to pi times diameter. So we know what our diameter is. It's 4. So it's just pi times 4. So shift that button there. That will give me the pi times 4. It should pop up with 4 pi. Press the SD button and get 12.56. Because the digit after, the critical digit is above 5, that 6 bumps up by 1, so it's 12.57. 12.57, and the unit is centimeters. That's all there is to it. If you can tell me the radius or the diameter of a circle, I can tell you what its circumference is using one of either of these two formulas. So the questions you need to tackle are from exercise 4B, page 200. You're looking at question 1, question 2, question 3, and they are all left-hand side. So 1, 2, and 3. With question 2, I want you to do A and B. With question 3, you can just do 3A and 3D. And we're also doing question 5, which is a worded question. So page 200 and page 201. That is it for exercise 4B. I'll see you guys in the next video. Bye-bye.